Welcome to video number 4 of a 4-part video series concerning the National Water Model Learning Module found on Hyrolearn.org. My name is Easton Perkins. I am a student at Brigham Young University and a research assistant in the Hydroinformatics Research Lab. Today we'll be going over how to complete exercise number 4 found in the National Water Model Notebook number 2 titled Mapping and Xarray. To access the learning module, open up a browser and search Hyrolearn.org. This will take you to their main page where you can simply type into their search bar National Water Model. Click on the National Water Model icon to join the learning module. Once you're here, it should look something like this. This page will help give you a basic understanding for what the National Water Model is. A brief introduction and a module overview is given. Section 1 explains the history of the National Water Model and why researchers thought it so important that a National Water Model was created and how it's developed recently. Section 2 will help you apply and understand exactly what the outputs of the National Water Model offer, such as short-range, medium-range, and long-range forecasts. Will help you explore the National Water Model interactive map. And today we'll be going over learning activity number 2, accessing the National Water Model through Python code. This video tutorial assumes that you've already worked through the previous steps and have a basic understanding for what the National Water Model is. Alright, we'll click here. This page is a setup page and it'll help you get started. You should have already created a Hydroshare account at the beginning of the learning module. This page also helps you get set up with Jupyter Hub. This video assumes that you have already done that. So we'll click here. And these steps are outlined on the previous page, but we'll go to Open With, Quasi Jupyter Hub, Python 3.8, start it up. Again, if this isn't working for you, it's probably because you don't have a Hydroshare account yet, haven't been accepted to the group, the quasi group yet, or any of those number of things it could be. Just go back and follow those steps on the learning module and you should be able to join. If you're having any problems, just ask your instructor for more help. Alright, we should now be at some page similar to these ones. Welcome. If your page doesn't look exactly like this, it's alright. There's different interfaces that are developer view and other views. As long as you can see somewhere where we have these links here, National Water Model, Notebook 1, 2, 3, 4, you're good. Today we're in Notebook number 2, so just click there. And it should open it up for you. Alright, and you should see some kind of title like Mapping and Xarray. That's how you know you're in the right spot. Alright, as is previously stated, this video is going to be going over how to complete exercise number 4. If you've not completed exercise 3, 2, and 1, I advise you to go back and do so before you do this. Video tutorials are provided as well for how to complete these. Alright, exercise number 4 states, using the National Water Model JavaScript map above, obtain reach IDs for a stream of stream order 2, a stream of order 5, and a stream of order 8. Try to pick streams that are relatively close to each other if possible. Build a time series for each stream's short-range forecast from yesterday using the functions in this notebook. Find the high flow for each of the 3 streams in the respective short-range time series and compare. Do your results make sense? Do the higher order streams have larger flows? What is the reach ID of the stream with the highest flow, and what stream order does it belong to? Where would you expect to find the reach or stream? Hint: when building the time series, make sure that you formatted the forecast start date like this. So in the following string format, so your first month and then day, and the reach IDs look like this. So in other words, the forecast start date should be a string and the reach ID should be integers. Okay, so this exercise really isn't too bad. If it's not making sense, we're going to go through it right now. Okay, we'll scroll up here to the top. Now, in previous videos, I explained what each of these cell blocks do with the Python code. I'm not going to be going through that in depth in this video. If you're curious or don't quite understand, go back and watch the previous videos. All right, so simple as that. We're just going to start hitting run. So hit the run button. Make sure a number pops up in the brackets. That's how you know that the cell's been run. This is importing our packages. This is getting our URLs, short range, medium range, long range, depending on what we want. This is setting up our variables. We'll hit run there. Xarray, getting that all set up. Organizing all the data that's going to come in. We'll just keep hitting run. Keep going. We're going to hit the plot. Keep hitting run. Mapping. Previous exercise went extensively over what happens there. For this exercise, it's not too important for us. So we're going to hit run again. Now this is where it's going to start getting important for exercise number 4. This code right here is setting up a map. And now this map's going to be just like the interactive map that Noah provides. If you haven't played with the interactive map or done those exercises found in notebook number 1, I advise you to go back and look at that. Basically what we did here is coded our own map with layering that brought all the rivers and streams in the continental United States. So you can see the streams and rivers. You can see if you click on one. Let's click on this one. Oh, scroll down just a minute. All right. So I clicked on that one. It gives us the object ID, shape, station ID, stream order, shape length. So pretty awesome. It basically does everything that the interactive map did for us, and we coded it up ourselves. So kind of fun. All right, so we're going to scroll down here. All right, so for this purposes of this exercise, it asks us to find in the same general area close to each other 3 types of streams. One of the order 2. Let's make sure we get it right. Stream order 2, 5, and 8. All right. So if you're a little confused on what a stream order is, go watch the last exercise. Actually, in exercise number 2, that really explains what orders are. But brief explanation here. Let's find a good spot to do this exercise. All right. And again, I've played around this a little bit before, just preparing for this video tutorial. So I kind of know where I want to look at. If we click right here on the Colorado River, you can see it has a stream order 8. Oh, that's what we're looking for. So stream orders go something like this. Stream order 1 is a really, really small stream. It's where it starts out. So it's probably going to be on top of a mountain range where, you know, the snow's melting and streams are just starting. As streams intersect with each other, they're going to upgrade in numbers, right? So you're going to get stream order 2, 3, 4, 5, all the way to 10. And the bigger stream order you got, the bigger the river. So as we can see, the Colorado River is a pretty major river. And when we click on it, you have a stream order 8. So that makes a lot of sense. All right, so we got our first value that we were looking for. So what I'm going to do here is we're going to copy the station ID. Oh, if I can get it to go. Okay, Control C. And we're going to come over here. And we're going to click run so we can get this input bar to come out. And we're going to paste it in here, our feature, our stream ID. So there we go. Okay, and once you get that, you can see this asterisk that's in the brackets right now. That means it's thinking we've got to hit enter on your keyboard. Enter. Not run, but enter. And that'll get it to go. All right, we're going to come down here. We're just going to keep hitting run. This is going to convert the reach from a string type to integer type. Here, the IPy widgets creates a menu. It's basically just creating the next step here. And we can choose medium range, long range. For this purpose of this exercise, it asks us to make a short range. So we're going to hit run there. And we're going to come down here and we're going to hit run. Now this is going to take a little while because it has to go out and grab the URL from the National Water Model site, so you can get all the data that we're looking for. And you can see over here it's loading. So be patient with this part. It'll take just a minute. All right, and we can see it ran. When these numbers pop up, we're going to hit run on the next cell, and it's going to plot it for us. Alrighty, so we can see we have a flow rate, cubic meters per second. Starting right now, it's at 298 cubic meters per second. And actually right now here in Utah, it is a rainy day. It's actually snowed a little bit today. So as we can see, the general trend is that it's going to increase in the cubic meters per second, or the flow rate, so which makes a lot of sense with the rain and snow that we've received. So awesome, it worked. It plotted short range forecast for us, and we are all good as far as that goes. All right, now it asks us to go back and look at, that was stream order of a value of 8. We need a 5 and a 2, and we need to compare them. Now, the best thing I can think of to do here is to compare them is, let's open up actually this same tab 3 times. And the only reason I want to do that is so we can compare these values. So we're just going to make a bunch. I just made one right here, duplicated it. I'm just going to open up a new tab, and I'm just copying and pasting the URL. Many different ways you can do this. This is the first way I can think of. So we'll just open these up, and there's going to be 3 there. Okay, so this is the exact same notebook, just open in a new tab. It's probably already run through the code, but we'll list for safety reasons. Go through, super easy to click through it, not too hard. Alrighty. So now that we're here again, we need another stream ID. So we're going to come back in the same general area. We can see here we were in Garfield County, right next to Bears Ears National Monument, right above Lake Powell, in that general area. Now, hopefully you don't pick the same area that I do. I hope you have your own experience and try to find these stream orders. But I guarantee you're going to find a little bit of difficulty finding in the same area, especially the same river, those certain reaches that we're looking for of 8, 5, and then make sure I say this right, and 2. So just be patient, take your time looking. If you can't find one, 3 is good enough. Just the object of this exercise is to understand the differences of stream orders and what the differences are going to be with the results. So I'm going to click back in here. So we have 8 again. Let's see how long this is going to take me to find the right stream orders. So we got a 3. You know what? We got a 2 right here, and that's pretty close. So we're just going to use this one. So we're going to Control C, Control V. All right, there we go. And we are going to hit enter, not run. Enter. I didn't click that. I hit enter. All right, so it's in there. We're going to hit run this time. On these ones, we want short range again. It's going to go and grab the URL. Again, that's going to take a minute. Maybe while it's doing that, we'll come over here, and we're going to run through all this code again. We went a little too far, and now it's thinking. I think what's happening, oh, yep. I bet it just ran here. Yep. So it didn't really want to go because it was still thinking here. So, all right. And we're going to hit run here. So we went back to our second tab. We're going to hit run. Now it's plotting. And I guess this might be a spoiler, but we can see all the data came in with zeros. So when it plots, and I'm surprised it's taking this long, it's just going to be a flat line. Now, that might not be the best example, but honestly, if we come back here, stream order 2s just are not going to be that big, have much flow rate because it's such a small order, right? I mean, it's starting from the beginning of the stream. We all know that the starts of streams and rivers start at the top of mountain ranges. And during the summer, those are going to dry up and everything like that, and depending on what you have. So I could go through and find another one. I think for the purposes of this exercise, I think I'm going to skip that. Hopefully it'll load here for us. Let's give it a few more minutes. Okay, and what I found real quick, I've been playing around with these different tabs, and I found that opening multiple tabs in the same notebook really confuses the code. So if it works for you, do it. But if not, here's my workaround to that. So we're just going to come in here, and we are going to do a screenshot. So I got a little screenshot function here on my computer, and we're just going to copy this just for a minute. So I got it right here. And let me open up a Word document. Perfect. And we'll just copy and paste it there. So let's remember, this is our stream order 8. We can make it look really nice. Stream order 8. All right. It doesn't have to look too nice right now because we just want to be able to use this to compare it. All right, so we're going to close that for a minute. All right, so now that we got this, now we're going to come back up here, and we're going to do what we were doing before. So we're going to come over here. Maybe we'll find a little bit different section of river, since the last one that we uploaded had zeros everywhere. So maybe stream order 1, stream order 2. Okay, so copy this one, Control C. Hopefully I haven't confused the code too bad. Hopefully it'll start working again. Looks like it's not. All right, I'm going to go through and I'm going to reset the code one time. All right, I just went through and kind of rebooted the code. I think opening up multiple tabs really freaked it out, so I wouldn't advise that technique. All right, so we're going to come back here right to where we were again, and Colorado River, and we're going to come over here, stream order 2. Where are you at? For, I think it's this one right here. Oh, no. Ah, there we go. Stream order 2. Okay. I'm going to copy this one. Control C. Control V. We're just doing what we did the first time again. Hit enter, not run. There we go. And we're going to hit run here. Run here. Run here. Short range again. Run. And run. Okay. And we're going to let that think for a minute. Of course, it's going to just take a few seconds because let's go out and grab the URL again. Oh, man, I went a little faster than I thought. Okay, zeros again. So if you remember, I pulled a different one last time, and they were all zeros as well. So that's good enough. So we're going to come up here, and I'm just going to screenshot this just so we can keep it for ourselves. Copy that for a minute. All right, and we're going to come here. And we're going to put in stream order 2. All right. Now let's go get our last stream order. And it's going to be stream order 5. All right. Close this for a minute. Scroll back up. Okay. Now we're looking in this general area, stream order 5. So it's going to have to intersect a few times, right? So this one could be it. Stream order 2. It's interesting. I would have thought it would have been higher. All right, keep looking. Stream order 4. We're getting close. 4, but we need another major one to intersect it. 3, 1. Man, 4. Man, we're so close. Let's broaden our views just a minute. All right, let's look right here. What's this one? I think it's 4 as well. Oh, 3. Yep. This is 4. We still got 4s. All right. And when you do this, it's probably going to take you the same trial and error process. It just takes a minute to find what you're looking for. If you can't find one, stream order 4 will probably be fine. Be better to have a little bit higher one, maybe a 6. Let's see here. We're going to find one. Maybe right here. 4. Lots of 4s. Where's a 5? 3. 8. Come on. All right, I finally found a river with a stream order of 5. I had to go way out the Colorado River. I'm actually here in Delta, Colorado, I believe. So I'm a long ways. You see, I took my other stream from over here, and we're way over here now. So if you can find one that's closer, do it. But for now, we're just going to take this one. So we're going to do Control-C. We're going to come back here. We're going to hit run once. We'll reset it and hit enter. We're going to come down here, hit run, run, run. It's going to go out and get the URL. It's going to take a few minutes, and we'll let it go. As soon as we get this, we'll compare them, and you are done with the exercise. Now, it does say do this for yesterday. We did it for today, but you just change the string for yesterday's date if you decide to do that. So we have that run, hit run here, and we got that as well. Sweet. All right, and make sure we're going to do this right now. Hit this run, so it'll delete all the files that we've downloaded to get all that data, so it doesn't fill up your Jupyter Hub notebook. All right, so we're going to come in here, do this process one last time, and open up our Word document. And there we go. All right, so now we're asked to compare them. All right, stream order 8. We can see that the maximum stream flow was just above 300 cubic meters per second. Stream order 5, so a little bit lower, was the flow rate max was 11.5 cubic meters per second. Stream order 2, pretty close to 0. It could be dried up, that stream or river, or maybe it's just so low that it doesn't really give any values. So interesting. So we can definitely see that the idea of a stream order is valid. It follows the data that we collected. Stream orders with a higher number, like the Colorado River is where we took this from, a big major river, has a huge flow rate. As we go to the streams that are feeding into the Colorado River or go way upstream, we can see that the stream order decreases. And as the stream order decreases, the flow rate also decreases until we get down to 2 or 1 where we have almost no flow rate. All right, that's it for this exercise. Hopefully that made sense. If you're curious, play around with what we did today, and hopefully you can continue to change the code and get what you want out of it. All right, that's it for this exercise.